Okay, so on which table and next data dictionary here observe user underscore indexes. So with the help of this user underscore indexes, okay now. So what I can see means I can see my index type. So that means are you created, okay, which type of index? Is it bitrina or bitmap now? Is it bitrina or bitmap index? So which type of index are you created? Okay, now the index types, if you want to see on particular column, so I can use what now? User underscore indexes. And in this, you have an index name. And this index is which type of index? And this indexes are you created on which table? Okay, now. So now when I want to see this, so I'm going to write here. So my index name, comma, my index underscore type. Okay, from user underscore indexes. Okay, so where table underscore name is equals to, so EMP table. Can you see on this EMP table? So we created different indexes here. These are indexes names. Understand now? So these are indexes names. And the index type is going to be showing like, so normal, normal, functional based index, normal, and bit index is called a bitmap. So here, this is called a bitmap index that we know. And we given the bitmap index name BIT. And here I1, I2, I3. These are the showing normal index type is what now? Normal. So here, what is the mean by normal means? The normal is nothing but default. So, and yesterday I said to you, default indexes are what now? B-tree. Okay, na? Yesterday I said to you, default indexes are what now? B-tree. So every normal index is called as a B-tree indexes. So that means here I1, I2, I3, these are the B-tree indexes. Okay. And BIT is called as what now? Bitmap index. So like you can see the index name and that index, which type of index. Okay, now right down below. Take note point. To view index type or index name, to view index type along with the index name, of a particular table, in Oracle database, then we use a data dictionary. So is called as user underscore indexes. User underscore indexes. And your normal index is nothing but default index B-tree. It is also B-tree. Okay, right. Okay, so this is the way you can see your index types also. Okay, and the next one is how to drop an index. And finally, whenever you want to drop indexes from your table, so you can use this syntax here. And this is common syntax for dropping of your bitmap index as well as B-tree index. Okay, now the same, both are same here. So let me see. I'm going to write in drop index I1, and suppose we are dropping drop index bit. So the both are going to be same as here. You can see. Suppose I'm going to drop here the index I1. So index was dropped. And if you want to drop the bitmap index also, BIT, it is also drop. So that means the both kind of indexes we can drop with the same syntaxes. And let me come out and see later your indexes are not there. I1 and I1 and bitmap. The both are dropping here, and I2, I3 was there. Okay, now? All right. So now you can drop like this, right on. Okay, so these are complete indexes, how to create and how to drop. Okay, and the next one is, okay, so text hiding cluster. Okay, here what is the mean by clusters? And when you want to create clusters in our database. Okay, now the first I will show you when you are not created clusters. Okay, you are not created cluster tables. What it was happen in the database. Okay, let me come out and see. So first I will explain to you diagrammatically. Okay, so now see the diagrams here. So non-cluster tables and cluster tables. So, and by default, okay, our tables are in which manner it will be saved means it will be saved in the non-clustered format. So what is the mean by non-clustered? Okay, non-clustered means here what it was happen. So now we are creating so many tables. So every table when we created, every new table, whatever we created here, that every new table is going to be saved under one separate data blocks in your database memories. Okay, now like every individual table. Okay, suppose I'm creating here. Okay, the three tables I'm creating. So first table I'm creating T1. The T1 is not a clustered table. It's a normal table or general table, or else we can say non-clustered table. So whenever I created a general table in my database, what it was happen, every table is going to be separately saved under data blocks, like table 1, like table 2, like table 3, like 4, 5, 10, 100, 200, whatever it is. So that means by default, whenever a user is created a new table, okay, in your database, and every new table individually will save under a separate data blocks. Okay, now it will be like this in your database memory. So whenever my tables are having like this and saving like this, what is the problem, sir? Okay, what is the problem? The problem is nothing actually. If you want to retrieve data from individual tables, separated tables. If you want to retrieve data, there is nothing problem. So select a star from T1 where condition. So particular table, I'm going to retrieving my data, a particular table. So whenever you want to retrieve your necessary data from individual tables, I don't get any problem here. So T1 table, I can get it. T2 table, I can write. T3, I can get. So individually, on individual tables or from individual tables, if you want to retrieval your necessary data, then you can happily write a select statement and retrieve your information. Okay, now, so there it is nothing problem to us. But the problem is where means that not individual, I want to retrieve, okay, I want to retrieve the group of tables data. That means I want to retrieve data from multiple tables. If I want to retrieve data from single table, I don't have any problem. But whenever I'm going to retrieving the data from multiple tables, then there is problem. Okay, what is the problem here? Let me see. So already we knows joins topic. And of course, whenever we want to retrieve data from multiple tables, definitely we are using what now? Joins. Yes or no? We are using joins. So now here also same thing. My requirement is what now? I want to retrieve the information from these three tables. But unfortunately, these three tables are non-clusters. Non-clusters means individuals. So separate, these tables are separate memories it will be having. So on these non-clustered tables, if user is going to be writing one join statement. So I'm writing join statement. Select a star from T1, comma T2, comma T3, where T1 dot common column is equals to T2 dot common column. End operator, T2 dot common column is equals to T3 dot common column. Condition you already knows that how we are writing the chain conditions in between tables. So when I'm going to writing this join statement, and based on this join query statement, if I retrieval data from multiple tables, that internal process is what, sir? Here observe. My internal process is, carefully observe. So our internal process is what now? Now here observe. First condition is there. What is the first condition? T1 dot common column is equals to T2 dot. This is condition number 1. Next condition is what now? T2 dot common column is equals to T3 dot common column. This is condition number 2. In between two conditions, we applied which operator? End operator. So first I have to divide my conditions like this. And now what it was happened? The first of all, the first condition will be check. The first condition I was written in between which tables? T1, T2. That means T1 table data, T2 table data. In my first condition, these two tables data comparing. Yes or no? Yes. Now, T1 table, T2 table, these both tables are comparing first. In this comparison, as per your equal operator, how many rows are matching? That all matching rows of two tables data will be saved into another data block memory. See, very interesting and carefully observed. So these two tables matchings as per given condition, whatever the matching rows are there, those matching rows information, again, it will be saved into another data block. That means it is what it is here? The result of a T1, T2 combination of data. And this result, the result set or result table will save into another data block number 4. Because already 3 data blocks are existing. So this is 4th block. Okay. This two tables comparison of data, whatever it was come finally, that again it will be keep into another data block memory. So it was keeping like this. Okay. Then after second condition, what is my second condition? T2 dot T3. So now these two tables, now it will be comparing now. After comparison of T2 and T3, again these two comparison of data, again what it will do, it will be saved into another data block memory. Another data block memory. Okay, na? And this is what we called as a data block number 5. Okay. Then after, whatever in these two conditions between, whatever I return, end operator, now the end operator will be applied on these two results of data. End operator. End operator again, data block number 4 result, data block number 5 result. These two things will be comparing. So end operator, what it was say, comparison of these two data, the two conditional data, wherever it is matching. Okay, that means matching means true, true. Then only retrieval, and the retrieval combination of result data, again it will be saved into another data block memory. Okay, na? This is final result. This final result after end operation, whatever the final result will come to you, and that result again your database server will save into another data block memory. And whatever the final result will come out here, FR, final result, okay, keep into another data block memory. And from this data block memory, it will be sending to your user application. Your user application. So the final result sending to user application. So this is internal process of a join execution statement. When means when your tables are non-clusters. Understand now? So whenever your table is individually, separately, if it will be saved in the separate data blocks, then this is the way how the join query statement internally perform. And now tell me, now if you see this entire this mechanism, what do you understand? Now your join query statement performance will be good or bad? Bad performance. That means your joins performance will be degraded. Why it is degraded means internally this much procedure is going to be happen. Okay, now so first condition is checking, and that result whatever it was come storing into one separate block. Next second condition checking, again that result will be saved into another data block. Again first result, second result, again combining by using of AND operator, OR operator, whatever it is. Again that two combination of data will check and finally give a result, and that result also saved into another data block memory, and from there it was sending to finally client application. So this much internal process is going to be happen. And just imagine here how many tables I'm taking? 3 tables. I'm taking only 3 tables data. Imagine when you're working in a companies, are you retrieving the data from 20 tables? And the 20 tables are in the non-clustered format. Then what happened? Just imagine. Here 3 tables purpose, this much process is going to be happen. If you have a 20 tables, and from the 20 tables data, if I want to retrieval by using of join techniques, then you imagine how much time it will take. It's a lot of time now. Yes or no? Yes. Here 3 table, 2 conditions. 20 table, 19 conditions. Understand now? N tables, N minus 1 conditions. 3 tables, how many conditions? 2 conditions. 20 tables, how many conditions? 19 conditions I have to check. That means 19 individual conditions results are keeping into 19 data blocks. So 19 data blocks, already 20 data blocks. 20 plus 19, 39 data blocks. And after that, end operator result. Okay, na? So that means those are again, okay, 19. So like you can go to compare like this, almost 40 to 50 data blocks are internally prepared by your server. And just imagination, this much process is going to be happen later. Finally, it will give a result. So, but what we thinking as a user, this internally what happened, we don't know. But we are thinking that, oh, okay, my result was came. My result was came. That I'm thinking that. But the result giving purpose, Oracle server internally, how much procedure is going to be done that nobody can knows. Okay, now. So, but here the cluster, non-cluster mechanisms are, this is the internal working nature. When your tables are in the non-clusters, on those non-clustered tables, if I apply my join statements, then it will be degrading my joins performance. Understand now? This is a problem of what now? Non-clusters. So to overcome this, what I need to do? I want to create which type of tables? Clustered tables. Okay, I need to create a clustered tables. Yeah, clustered. Cluster means what now? The group of people together having in the same memory. The group of people are together having in the same memory. Otherwise, the group of people, okay, having or sharing same memory. For simple example, I want to tell you. Nowadays in your hostels are there now? So I think in Hyderabad, individual rooms also provided. Yes or no? And group of people are having in the same room. Okay. Suppose there are 3 friends are there, for example. The 3 friends came to Hyderabad to learning some courses or whatever it is. They're coming from outstation, and the 3 are best friends. But these 3 friends decided to stay individually. So they went to an hostel. They approached to hostel management people, and they said, yes, we also provide individual rooms also. But for Ed, we will charge 10,000 rupees. Then these guys are, okay, no problem, we will be paid. Then what happened? This guy was 10,000. This guy was 10,000. This guy was 10,000. 30,000 rupees monthly, the 3 people are paying. And they are having individually. This is called as what? Non-clusters. But the same people, if they are intelligent people, what they are doing that? Why should we want to go individual rooms? We 3 people together having in the same room. Then it will be expenditure 15,000 rupees. Then which is better? Here 30,000, but a single room, 3 people, 15,000 monthly. Which is better? Single room is the best for you or individual? Single room. Money save. Expenditure save. Yes or no? And when you people together having in the one room, if any problem is come, they can solve it. But when the individual people are there, if any problem will come, the problem doesn't know other person, what it was happen here. Okay, now? So when you comparing like this, okay, here, the unity is not there. Performance will be low. Here, unity is there, then performance will be high. Whenever unity is more, their performance also very good, high standard performance. When there is no unity in between the people, then there is no performance here. Okay, now? So this is simple logic. So that is called a cluster. Cluster means what now? The group of people are sharing same room. That is called a cluster. So money save, you in between you have some unity, and performance also having some good. But here individuals. So very delay performances, expenditures are more. There are a lot of drawbacks are there here compared to here. Okay, now? So cluster means what you understand here? Group of people sharing same room. That's called a cluster. So here also you can see these are individual rooms and the 3 people staying in individually. More expansive here. Here more expansive. But here the 3 people together they are staying in one single room. Then here less expansive here. Okay, now? So now we can see in this case what it was happened. What I'm doing here, the initially, that means whenever we created a table, so these tables are I created under clustered format. Which format? Clustered format I'm creating. So at the time of table creation only, these tables together I'm going to link. Link means connectivity we did, and the connecting tables, already connecting tables, or at the time of cluster creation time, we are connecting these tables, and these connected tables are saving into one memory. So now we can see I'm going to connecting these 3 tables. But whenever you want to connecting these 3 tables together and keep into one data block memory, then compulsory in these 3 tables, you have a common column name. So without a common column name, you cannot create a clustered tables. Okay, now, so that means how many tables you will be clustered, you will be together. Okay, every column or every table should have a common column name. So your common column name is there what now? X. Your common column X. So based on this common column, every table at the time of cluster table creations only, table to table will be having links. Okay, it will be linked. Yes or no? And those linked tables, they're keeping under one data block memory. So whenever these three tables are having in the same data block memory, then on these already linked tables or already joined tables, I am performing my join operations. Then what it was happen when I'm writing the same query request on these joined tables, then what has happened? So again, these conditions will not check because already tables are linked together. So directly, which one is checking? End operator. So end operator is directly performing on these three, okay, linked data, and directly that final result will keeping into data block, and from the data block it was sending to user application. So here how many levels are happen? With one level your final result will come, but there first condition checking, data is combining, later second condition checking, data is combining, again this condition results are again comparing by using end operator, and finally it will give some result. So it was a lengthy process to produce your result. That's why my joint performances are degraded here. And here joint performance is high, that means fast, quickly, fastly, it will be written your output. Your output producing is very, very fast. Their output producing is very slow because of reason that individual operations. But here already my tables are joined together, and joined tables I'm keeping into one memory. Understand now? And now from there directly you will take your required data. So that is the reason your joints performance will be improve us. Your joints performance will be degrade us. So, and if anybody asks you why we want to create a clusters, okay, the main purpose of cluster, main cause of clusters means to improve joints performance. This is a concept. Okay, now other than this, there is no other advantage of cluster. Clusters are created, cluster tables are created. Only the reason is to improving joints performance. Okay, if you are going to individual, joints performance will be degrading. Lot of time consume a process, and getting output is very, very slowly. But here, once your tables are already in the clustered format, then directly attack my data to retrieval. Again, I don't need two tables connected after comparing. It's not necessary here. Understand now? So this is the main cause of your clusters. So finally, what do you say? Clustered is nothing but, as per this, what do you say? Clustered, what do you say? It is a database object. It is a database object, okay, which contain the group of tables, together, okay, together to share same data block memory. Group of tables together to share same data block memory. Next, clusters. So cluster, main intention of cluster is what now? Okay, clusters are created, okay, to improve the performance of joints. To improve the performance of joints. Next one. When we created clustered or cluster tables. When we created cluster tables, then we should have, then we must have a common column name, in in tables. In tables, and this is mandatory, guys. Okay, na? Not optional. Common column name in tables. And this common column name is called as clustered key column. Clustered key column. Okay, the next one. These clustered memory is created. So memory created, or these clustered tables, not memory, clustered tables are created at the time of table creation, at the time of creating tables. Okay, but like somebody is asking, sir, on existing tables, can I create a cluster memory? Means impossible. You will be created these clusters at the time of creating tables only. After table creation, can I means not possible. Okay, na? After table can I means not possible. It will be at the time of creating tables only possible to create a cluster tables. Okay, now after that it is impossible. Okay, so these are some information about clusters. But these clusters, when you want to create, okay, when we create clusters, then we follow the following three steps mechanism. Okay, 3 steps mechanism. Okay, now first step number 1. What is my step number 1? Create a clustered memory. This is step 1. And in this, how to create my cluster? Have a syntax. So create clustered and should give it here cluster name of a, then I should take it here common column name and give it your data type and size. This is step number 1. Step number 2. After that, create index on clustered. So the syntax of creating index on clustered memory. So create index and index name on clustered and give it your clustered name. And after that, I will go for step number 3. Create clustered tables. So here the syntax to create cluster tables. Okay, now. So first, as usual, you know how to create your table syntax and pass your column name 1. Okay, and how many columns you want it. So as usual, that all columns you can go to mention as per your requirement. Okay, the required columns. And finally, you can add your cluster tag, cluster name of common column name. Okay, now? So these are the 3 steps we need to follow it here. And let me come out and see how these 3 steps I just followed now come back. First observe mechanism, later I will give it notes. So first of all, what I want to do, I want to create my cluster memory. So create cluster and cluster name. I'm passing here some name as your wish. Any name you can give it with some common column, department number I'm taking. So this is one cluster, but we don't have any privileges. So I want to take privileges now. From where? From administrator. Who is our admin? System. So now he will give it a, okay, which permission? Grant, create, cluster to MyDB 9 a.m. And after MyDB 9 a.m. user is connecting to your database. Okay. And then he will create your cluster. Okay. Now the cluster is created now. After created, now I want to create my index object. Okay. CI on, okay, clustered. And my cluster name. What is my cluster name? EMP underscore DEPT. Now index is created. And after that, you can create your cluster tables. For example, EMP1. Okay. EMP1 is there already? Huh? Okay, let me try. So now I will take EID, ENAME. So varchar2 of some size. And here I will take it common column is what now? Department number. And this table, what I'm saying here, at the time of table creation only, I can cluster. But after table creation, can I cluster means impossible. That's why you need to add your tag. What is the tag? Clustered, cluster name. What is the cluster name? EMP underscore DEPT of DEPT number. That's DEPT number is what? Common column name. Let me try this. Okay, EMP1 is already existing. Okay, fine. Okay, my cluster table created. After created my cluster table, the another table I'm creating, second table, DEPT1, and I pass here. Okay, so department number is an integer, and next I will take department name, varchar2 of some size, as well as this table is also, I will add it to my cluster memory. I'm adding to my cluster memory, clustered, cluster name, and which column basis? DEPT number. And see, DEPT number is a common column in these tables. And now two tables are created. After that, I'm going to insert some records into EMP1. In EMP1, have a 1 and the employee name Smith, department number 10. Same as, okay, ID number 2, the name was Jones and department number 20. I just made it commit here to permanently save my data. And next, second one is what now? Insert into DEPT number 1 and sending values. So here first one is what now? Department number, department name D1. And the next one is called as here department number 20, department name D2. And here also I just made it commit. Okay, I just leave. And finally, these two tables when you call here, okay, these two tables when you call here, this is your tables information. And now you will get some doubt. Okay, sir, as per the step 1, step 2, step 3, the cluster tables we are created. Okay. And after we inserted some data also, then how I knows these two tables are having in the same memory? That is my doubt, sir. How I know it, how I can see it. These two tables are having in the same memory. Okay, now that kind of doubt is come now? Yes or no? Yes. So how I knows these two tables are already in the clustered. Okay. How you know means if any interview person is also asking this question and you check it out, when these two tables rows are there, this is row 1, this is row 2, this is row 1, this is row 2. If these two tables row IDs are what? Permanent or temporary? Permanent. And we all of you know this. When you insert a new row, for every new row inserting time, system internally created row identification address or identity that already we discussed in the subqueries concept. So here also, these two tables are having in the same clustered memory or not. That is my doubt, sir. Okay, now then the doubt, how can you clarify means, these two tables row IDs are, check it out. If these two tables or row IDs are showing same row IDs, then both are having in the same memory. If both tables or row IDs are different, then you can say these are not a clusters. For example, simple manner. Here, there are 5 friends are there. These 5 friends are staying in individual rooms. Okay, 4 friends are otherwise. So, friend 1, that is called user 1, U1, staying into room number 101 is room number. Another user, user number 2, he was staying under room number 102. So nowadays you can go to any hotels, rooms are there. The customers, passengers can be staying. Okay. So like this, here, another person is there. The room number 3, okay, user 3, this room number is 103. Another user, user number 4, he was staying under room number 104. So here the concept is what now? 4 users are staying in 4 individual rooms. Clear? Now suppose if I'm asking to my user 1, what is your room number? If I'm asking to user 1, what is say? 101. If I'm asking user 2, 102. User 3, 103. User 4, 104. So that means when I'm asking to user 2, he will say my room number is 102, sir. If I'm asking user number 4, what is your room number? Means my room number is 104, sir. So guys, I didn't understand these 4 users, why they're telling different room numbers? Huh? Why these 4 people, when I'm asking U1, he was saying one room number. When I'm asking U3, he was saying another room number. U4, another different number. U2, another different number. Why these 4 people saying the different numbers to me? Because they are staying like that. They're staying like that. And that means when these people are saying different room numbers to me, then I can understand that these people are not staying in the same room. These people are staying in different rooms. Can I understand? Can I understand or not? Yes. So now tell me, this is a clustered or non-clustered? Non-clustered? Same as in the second scenario, these 4 people staying in one room. The room number is R101. If I'm asking to user 1, what is your room number? User 2, user 3, user 4. So these all 4 people saying same room number. It means what I can understand? These 4 people are having in the same room. Like simple examples here. Now there are students are there. The 3 students come to me. Okay, they're talking to me and I'm asking, what is your hostel? Hostel name means he was saying different name. My hostel name is so-and-so, sir. He was saying that my hostel name is so-and-so, sir. He was saying that my hostel name is so-and-so. So different students telling different hostels. That means there are same hostel or different hostels. different hostels. That's why they're telling different names. But some more 3 friends came. There are friends. I'm asking these 3 friends, where are you staying? So these 3 people saying same hostel name. That means these 3 people are having same hostel. Here, different hostels, non-clustered. Here, clustered. So clustered, how I know these people are clustered means when they're staying in the same hostel or not. If these 3 people saying same hostel name, then I can confirm that these 3 people are clustered, staying together. I can understand. When these 3 people are saying different hostels, then I can say these are non-clustered. They are not staying together. They are staying individual hostels. Okay, na? Concept clear? Up? Same as. Now here, how many tables I have here? 2 tables. In 2 tables, how many rows? 2 rows, 2 rows. Here first row, second row. Here first row, second row. So my first row, row ID. My second row, row ID. If showing same row IDs, showing same row IDs, then what I can understand? These 2 tables are clustered or non-clustered? Clusters. Okay, na? That is interview question. Compulsory it will be asked you, and that question answer you can show like this. Okay. Now select a row ID from EMP1. Okay, na? Select a row ID from DEPT1 and compare. First row compare. Second row compare. Same IDs are, different IDs are. Same IDs are. Okay. So same IDs are showing us. There is no difference. That means both are telling same room number. It means both are having same room, same data block memory. This is the way you can make it. Your tables are under clusters or not a clusters. That is one way. Second way, you can show like this. Select a star from tab. When I call this select a star from tab, can you see tab means what? List of tables. We can see it. And here, I just created my EMP underscore DEP. It is what now? Clustered. In this clustered, how many tables I have? 2 tables, EMP1 and DEPT1. And these 2 tables ID numbers 1, this is called a clustered IDs. Clustered ID. So clustered ID it was showing 1 and 2. That means under this clustered memory, how many tables you have? 2 tables. If you have a 3 tables, 1, 2, 3. If you have a 5 tables, 1, 2, 3, 4, 5. Okay, now? So that means in my clustered memory, how many number of tables I have it based on this IDs you can identify. That is one thing. Otherwise, if you want to see user underscore clusters, this is one data dictionary. In this data dictionary, your clustered memory name, you want to view it, then you can call clustered name from user underscore clusters. Cluster created a EMP underscore DEPT is my clustered name. In this cluster, how many tables are there and what are there? If you want to see, you have another data dictionary, user underscore tables. So in this user underscore tables, so you have what now? Clustered name. You have what now? Tables name. Okay. Let me come out and see in my cluster, how many number of tables are there and which type of tables are there? What are those? If you want to see this kind of information, then you can follow this. User underscore, what is this? Tables. And condition is what now? Where clustered underscore name is equals to, what is my cluster name? EMP underscore DPT. Now see, in this clustered memory, how many tables you have? 2 tables. What are those? EMP1 and DEPT1. So like this, different mechanisms you can show whether these 2 tables are clustered or not. If it is not a clustered, then it will not showing it. Okay, what it was showing here? No rows. So in this memory, if there is a no tables, nothing will show. But here already in this memory, you have a 2 things, EMP1 and DEPT1. Clear na? This is clusters how to find out, and cluster tables also how to find out. Now write down one by one step. Check it out up to where you written. The theory completed. Next, go to your step 1.
Recording in progress.
And based on these 3 steps below, take example. Now I will give it one by one. right now? Okay, and now below write down note. If we want to check these tables are clustered or not, then which then we check row IDs of these tables. If both tables row IDs are same, then these are under clustered. Otherwise non-clustered. చిన్న రూమ్ ఖాళీ ఉన్నాయా ఒకసారి తీసుకో. 11 ప్లస్ ఎందుకంటే 2 తక్కువే కదా. ఓకే డైరెక్ట్ వెళ్ళిపోవచ్చు కదా. అక్కడ 11 చెప్పుకొని 2 కూడా అక్కడే 2, 4, 6 అక్కడే ఇంకా కంటిన్యూస్ అక్కడ ఉండొచ్చు. ఓకే ఫోన్ చేస్తాను సార్ని 11 ఆన్లైన్ బ్యాచ్ చిన్న రూమ్ అయినా పర్లేదు ఖాళీగా ఉంటే చెప్పేసాను. పైన 5th floor లో ఉన్నాయనుకుంటా చిన్న రూమ్స్ అయితే 2 ఉన్నాయి. ఒకటి ఉంది డోర్ లేదనుకుంటా. కాదు నార్మల్ గా ఒకటి ఉంటుంది సార్ లంచ్ చేస్తారు కదా అక్కడ ఒక చిన్నది ఉంటుంది.
సెట్ అవుతుంది.
నెట్ ఎక్కడ వచ్చిన ఫస్ట్ అదే అనుకో, నార్మల్ క్లాస్ రూమ్ లోనే ఏమైనా ఖాళీగా ఉందని అడిగి ఫస్ట్. టూ కాదు,
ఇప్పుడు
11 o'clock.
సారీ, ఇప్పుడు ఒకటి 11 కి కంటిన్యూస్ అక్కడే ఉంటారు.
అదే 11 కూడా నేను అక్కడికి వెళ్ళిపోతా. 11ది సార్ది ఆన్లైన్ బ్యాచ్, ఓన్లీ ఆన్లైన్ బ్యాచ్. ఏమైనా చిన్న రూమ్ ఖాళీగా ఉన్నాయా అని అడుగు. సార్ చిన్న రూమ్ లో కూర్చొని చెప్పుకుంటారు అని అడుగు. ఉన్నాయంటే సరే అయితే సార్ వస్తారని చెప్పాను. లేవంటే ఇక్కడ వెళ్ళిపోతారు. న్యూ బ్లాక్ క్లాస్ లోపల చెప్పేసా. Okay. So this is the way you can find out your clusters. And the next one you can see, write down. To view all clustered objects. To view all clustered objects in Oracle database, then we use a data dictionary. Then we use a data dictionary. Dictionary is, what is that? User underscore clusters. Okay, this is one thing. And another one is what now? To view clustered tables in a clustered memory, then we use a data dictionary. Dictionary is user underscore tables. Okay, so these are the two data dictionaries, sir. Okay, remember to whenever you want to view clustered and clustered tables, right? Okay. And the finally, if you need to drop your cluster, okay, how to drop a cluster? The syntax of dropping a cluster. So drop cluster, and I want to give my cluster name. Okay. So including tables. Okay. And you are asking, sir, why are you using including tables? Okay, now it means what now? You're observed. Actually, in my clustered emp_dept, you have a tables. That means this clustered memory is not a empty. Is not a empty. It is having some tables. It's not a empty. It's having some tables. So that's why when I drop like this here, drop my cluster name emp_dept. If I'm not using including tables, it was showing to me error. And what it was say, clustered is not empty. Is it right or wrong? Right. Because clustered is not an empty memory. In this memory, what we have? Tables. So EMP1 and DEP1, two tables are there. So that's why whenever you want to go for to directly drop your cluster, it was showing like this. So that's why what I want to do, I want to add your statement. What is that? Including tables. Then if I executed now, cluster drop. And after dropping clustered, what it was happen, along with your clustered memory, in this memory, how many tables you kept? All tables are deleted. That's why what we said, we are dropping clustered memory, including tables. And let me go and check it out. So now see in your data dictionary, I'm seeing that in my cluster memory, you have any tables? No. Okay. And the next one is your clustered is there or not there, you can see. Okay. If you see this, do you have any clustered? No. And even though, can you call in the tab list? See in the tab list, do you have any clustered? No. Clustered is not there. Along with cluster, what it was not there? Tables also not showing to me. Okay, na? Not showing to me tables also. Okay. So this is when you want to drop your cluster, compulsory including statement should be used. Right down below. Okay. So these are the finally the clusters, how to use, created, and purpose of clusters. Okay. And this diagram in your main notes, in main material, this diagram is there. Okay, you can go to check it out. Understand now? Yes, okay. So, and this is cluster. And tomorrow we will go for one and two more topics are there in SQL that we will start it in tomorrow. Okay, na? Right. Yes. Thank you. Thank you so much.
అదే చెప్తాను. కంపల్సరీగా ఏంటి ఒక్కరోజు గ్రూప్ చేంజ్ చేసింది ఎవరు చేంజ్ చేశారు నిన్న మరి ఏం చేయాలి నేను అప్పటికి సార్కి చెప్పాను ఇప్పటికీ సార్కి చెప్పాను సార్ హెచ్డిఎంఎల్ ఫుల్ వస్తారు కానీ అది వచ్చి ఆఫర్ అయినా డిజైన్ అక్కడ ఇంకొక ర్యాక్ నాగబాబు నాడికి వెళ్తారు అంటే లేదన్నాడు అక్కడ హెచ్డిఎం 70 మంది 80 మంది నాకు తెలిపారు చెప్తున్నారు నేను చెప్పాను అప్పటికి సార్ ఫోన్ చేసి నాగబాబు చెప్తే అప్పుడు కిషోర్ గారిది 150 వస్తా చేంజ్ అనుకోండి ఇస్తాను మరి అదేదో ముందే చేయాలి కదా నాకు చెప్తే డైరెక్ట్ మిమ్మల్ని అక్కడ పెట్టి 2, 4, 6 అక్కడ చెప్పుకుంటారు 2, 4, 6 3 దాకా కంటిన్యూ అక్కడ మందిరంలో లేదన్నా నేను 320 నేను ఉన్నప్పుడు 320 మనం చెప్పండి నాకు అక్కడ సీసీటీవీ చూసుకొని పరిగెత్తాను అక్కడికి మీకు చూపించాను ఆల్రెడీ బయట ఉన్నారు సార్ అని చూసుకోండి